Each mobile communications generation represents a breakthrough. This time for the 6G would be the omnipresence of the mobile network, both for industrial and mass market customers. The importance of this challenge was appreciated by the FUSECO Forum conference organizers. A separate track was devoted to the problems of integration of terrestrial and non-terrestrial networks. In terrestrial networks, we talked about user mobility. For the IMT 2030 system, the future 6G, it's assumed that it will support mobility at the level of 1,000 kilometers per hour, which is the user on board of the aircraft, while for 5G it was 500 kilometers per hour. It was just the high-speed train. In the case of satellite systems, we have to deal primarily with the infrastructure mobility. The LEO satellite, low Earth orbit satellite, which ensures low latency, moves at the tangential speed of about 27,000 kilometers per hour, and its visibility time is counted in minutes. Satellites orbit over subsequent countries, appearing in subsequent networks. The network topology is very dynamically changing. Handling handovers become a much more complex problem. Base stations and user equipment must use advanced methods of Doppler shift compensation. The artificial intelligence is present in various areas in the ITER project. Its task is to support the end-to-end optimization of network performance, also in predictive analytics. In addition, the artificial intelligence supports decisions regarding the handovers. It also plays a role in the Doppler effect compensation, where it is used for the selection of the proper waveform, proper modulation according to the situation. In the ITER project, an innovative approach to data is also used, the semantic analysis, which focuses on information contained in the data to avoid inefficient transmission of data without meaning, for example, too often or too late. The ITER use cases will demonstrate precisely this aspect of the network's omnipresence promised by the 6G. They are selected for showcasing highly illustrative scenarios. Communication support for IoT applications immune to delays and intermittent satellite visibility, seamless smartphone support via terrestrial and satellite networks, and the communication for aviation application with high safety regimes. During the conference, one could listen to presentations of various research projects in the area of integration of terrestrial and non-terrestrial networks. The basic conclusion is that the ITER project is in the mainstream of the main approach, and at the same time we propose innovative, detailed solutions in the area of management and orchestration, network and service architecture, or specific enablers, for example, infrastructure mobility management framework, store and forward mechanisms, and distributed core, SDN-based user data path in the integrated network, or semantics analytics.